Have you ever wondered why some particles have mass while others do not? This is where the Higgs boson comes into play. Also known as the God particle, the Higgs boson is a force-carrying particle intricately tied to the Higgs field. This field is not localized to a particular space. It pervades the entire cosmos, interacting with other particles and granting them mass. The Higgs boson was proposed in the mid-1960s by physicist Peter Higgs. However, its existence remained a theory until July 4, 2012. Thanks to the Large Hadron Collider at CERN in Switzerland, the Higgs boson was finally brought to light, confirming the hypothesis and completing the standard model of particle physics. This model provides us with a detailed understanding of the subatomic world. And so, the elusive Higgs boson, often referred to as the God particle, was finally discovered. Why do some people call the Higgs boson the God particle? It's a question that's bounced around since physicist Leon Lederman penned his 1993 book, The God Particle. If the universe is the answer, what is the question? This catchy nickname quickly caught on, capturing public imagination and catapulting the Higgs boson into pop culture fame. But let's be clear, many physicists raise an eyebrow at this celestial moniker. They argue that it oversimplifies and even misrepresents the particle's true nature. The Higgs boson isn't about divine creation or esoteric mysteries. Instead, its real significance is rather more down to earth, but no less profound. The Higgs boson is key to understanding why some particles have mass while others, like photons, do not. It's about the fundamental workings of our universe, about the unseen fields and forces that shape our reality. Despite its grand nickname, the Higgs boson's true importance lies in its role of assigning mass to particles. What makes the Higgs boson so important? That's a question that has intrigued scientists for decades. The discovery of the Higgs boson was not just about finding a new particle. It was about confirming the existence of the Higgs field, a fundamental field of energy that permeates the entire universe. Picture the Higgs field like a cosmic ocean, invisible yet omnipresent. Other particles swim through this ocean, interacting with the Higgs field. The more a particle interacts with the Higgs field, the more mass it acquires. Without the Higgs field, particles would zip around at the speed of light, remaining massless. The universe, as we know it, would be vastly different. Stars, planets, you, me, none of these would exist. This means that the Higgs boson is not just another particle. It's a key to unlocking the nature of reality itself. It helps us understand the fundamental building blocks of nature. It tells us why particles have mass, and by extension, why matter, why everything around us exists at all. The Higgs boson, in its interaction with the Higgs field, is therefore a linchpin in the grand scheme of the universe. It's like a cosmic conductor, orchestrating the symphony of particles that make up the world around us. In essence, the Higgs boson helps us understand why matter, as we know it, exists. What are some of the technical details about the Higgs boson? Well, let's dive into it. The Higgs boson is a heavy hitter in the subatomic world with a mass of 125 billion electron volts. To give you a sense of scale, that's about 130 times more massive than a proton. Interestingly, the Higgs boson is devoid of any charge. It's a neutral particle, neither positive nor negative. And when it comes to spin, a property that many particles exhibit, the Higgs boson is a bit of an oddball. Unlike most particles that spin like tops, the Higgs boson has zero spin. Yes, you heard it right, it doesn't rotate at all. But don't let its lack of spin fool you. As a boson, it has a significant role in the grand scheme of things. It mediates interactions between particles, much like how photons mediate electromagnetic interactions. In simple terms, the Higgs boson is like the glue that holds other particles together, giving them their mass. So there you have it, the Higgs boson, a key piece of the puzzle that explains why matter has mass, and its discovery, a monumental achievement in the field of physics.